Okay, so I've added in some target y values up here so that you can see what it looks like it's approaching. So we've already taken a look at the limit of x approached -5 and found that both the right hand and the left hand one-sided limits agreed, and so we have a two-sided limit of 5. We found the same thing as x approached -1 from the left and as x approached -1 from the right. Those two limits, the one-sided limits, agreed. So we do have a two-sided limit. And we're now going to take a look at the last two, which is the limit as x approaches 7, which would be along this vertical line right here, and when x approaches 12, which would be along this vertical line here. So first we want to take a look as x approaches 7, and I've already done the work for you down here, so I'm going to kind of cover it up so you can see what's happening. So what happens as x approaches 7 from the left? So again, the vertical line when x is 7 is here. So from the left means from the negative side of the axis. So we kind of trace out our function. We follow it all around till it gets closer, closer, closer. We're never going to get to 7, but we get to 6.9, 6.99, 6.9999, forever, never, never. But if I never get to 7, then I never make this jump up here. So my y value still looks like it's going to hit this y value, which is -5. So the limit as x approaches -7 from the left is -5. So now the question is, what happens as it approaches from the right? So if we're looking at it as it approaches from the right, move it just a little bit so you can see, as I come from the right side of the number line, then I have to jump down. I'm coming from the right, so 7.9, 0.8, 7.7, 7.6, all the way down 7.01001. Clearly, this looks like it's going to hit up here at the y value of -2. So the limit then as x approaches 7 from the right side is -2. Now we have a problem because these are not the same number. So are we going to have a two-sided limit? If you trace your hands at the same time, does it look like your fingers are going to touch? Well, no, they don't touch. They don't come together, which means that we do not have a two-sided limit at 7. It does not exist, D&E. So you probably have already figured out what's going to happen up here at 12, because if you just take your fingers and you run it from the left with the negative sign in the power position, and from the right with the positive side in the power position, do you see that these fingers don't come together? Well, then you already know there will be no two-sided limit at x equals 12. However, there will be one-sided limits. So now we're going to take a look as x approaches 12 from the left. So as we're approaching 12 from the left, and again that means from the negative side, tracing the graph, coming closer and closer, 11.9, 11.99, 999, 11.9999. It looks like it hits the y value of 4, which means that the limit as x approaches 12 from the left, which actually means you're moving to the right, this is going to be 4. Now what about the limit as I'm approaching from the right, which means I'm actually headed left. So I'm coming from the right, it looks like it hits the y value of 8. These two numbers do not agree, therefore the two-sided limit at 12 does not exist. Hopefully this helps explain how you can find the one-sided limits and the two-sided limits from looking at the graph.